Hello, welcome to the session of learning. Today in this session, I will describe about the respiratory health and what are the factors responsible for deterioration of the respiratory health, particularly in context of asthma. Because in India, most of the peoples are suffering from asthma and they have to take precautions to prevent the damaging effect of asthma. Now, actually, the asthma problem gets aggravated more it becomes more worse when there is increase in ground level ozone concentration. Here we will explore how ozone O3 is going to impact the respiratory health of people who are suffering from asthma and also people who get infected from the asthma due to this ozone emission. Now, what happens? Ozone is the pollutant which is not directly emitted from any industrial source or vehicular emissions. Actually, it is a secondary pollutant which is generated in the atmosphere when the area is highly congested by traffic and there is also the industrial activities going on in the urban areas, especially urban areas where there is high traffic and industrial activities. So, in that area, what happens during the summer season when sunlight is present, then people get affected by this problem and they cause the respiratory health deterioration in the people, notably in individuals with asthma and the people who are already affected by asthma, they get more worsen effect. Now, exposure to elevated ozone levels can lead to airways irritation. Airways, that is the passage of the air in our respiratory systems, it gets irritated and exacerbated asthma symptoms and trigger the respiratory distress. This impact is characterized by increased respiratory symptoms, decreased lung function, and high risk of asthma attacks. Now, vulnerable people, that is mostly children and elderly peoples, are at a great risk, you can say. So, efforts should be made to mitigate these health risks, and this can be done by monitoring the air quality, implementing the emission reduction strategies, and raising the public awareness about the connection between the ground level ozone and respiratory issues, especially in the context of asthma. Now, for better understanding, here we will explore formation of the ground level ozone O3. What happens? Ground level ozone is not directly emitted into the air atmosphere. Instead, what happens? It is formed when pollutants released by vehicles or industrial facilities and other sources undergo chemical reactions in presence of sunlight. The precursor pollutants are nitrogen oxides and volatile organic compounds, VOCs. These are the chemicals, these are the pollutants which are responsible for formation of ozone. The formation of ground level ozone involves a series of complex chemical reactions. What are these? Primarily, these are driven by the pollutants like nitrogen oxides and VOC, volatile organic carbons, and sunlight. This process is referred to as photochemical smoke formation. The key precursors involved as I already said, that is nitrogen oxides and volatile organic carbons, VOC. In the presence of sunlight, especially the ultraviolet rays, ultraviolet light, the photochemical reaction begins. What happens? Solar radiation provides energy needed to break the bonds of the nitrogen oxides and volatile organic compounds, and a chain of reaction starts. Nitrogen dioxide is a key intermediate product in the initial stage of the reactions. In the presence of the sunlight, nitrogen dioxide absorbs ultraviolet radiation and it dissociates, it breaks to form nitric oxide NO and an oxygen atom O. The oxygen atom O then reacts with the molecular oxygen O2 present in the atmosphere to form ozone. The precursors such as oxygen radical and O3. The reactions involve NOx and VOCs, that is NO2 absorbs the ultraviolet light, it breaks into NO and O. Then O combines with the oxygen and it makes O3, and the a third party carries away the energy which is released during this process. Now, VOC also plays a crucial role in ozone formation. What happens? They react with the oxygen radical O, which is emitted by the breaking down of the NO2 to produce additional ozone precursors and contribute to the ozone production cycle. Thus a chain of reaction, you can say, is established. That is O plus RH, that is, you can say, volatile organic carbon, and it forms NO2 and nascent oxygen, atomic oxygen. These reactions involve VOC's further contribution to production of nitrogen dioxide and ozone precursors. While ozone is being formed, there are simultaneous reactions that lead to its destruction. The balance between ozone formation and destruction determines the overall ozone concentration in the atmosphere. And this is the reason why ozone concentration in the atmosphere increases. The overall process is highly dynamic. It is very dynamic process and depends on the factors such as sunlight, temperature, humidity, and concentration of the precursors pollutants, that is, you can say, nitrogen oxides and VOC, volatile organic compounds. This mechanism is more prominent in urban and industrial areas, as I said earlier, and with high emission of where there is high, you can say, high traffic and industrial activities, then there is high emission of nitrogen oxides and VOC, volatile organic compound, where sunlight drive the photochemical reactions and lead to formation of the ground level ozone, and the associated problems is with the air quality and respiratory health of the people residing there. Now, in urban areas characterized by heavy traffic and industrial activities, there is often a higher concentration of nitrogen oxides and VOCs, volatile organic compounds. During sunny days, the combination of these pollutants and sunlight facilitates the formation of ground level ozone, and this is the place where problem is created. Ozone, when present at a high level in the air, can irritate respiratory system, and it has a particular affinity to the lining of the lungs and airways, and individuals, especially those affected by asthma, may experience irritation and inflammation of the airways when exposed to high levels of ground level ozone concentration. Again, for individuals with asthma, inhaling ozone can trigger asthma symptoms and exacerbate existing respiratory conditions. Now, ozone exposure can lead to increased bronchial reactivity, making the airways which is present here, more sensitive to other asthma triggers. So, during the summer season and where there is high traffic levels, cities, especially cities with high traffic level, and when the summer is hot, also sunlight is very abundant, then there is increased asthma related hospitalization, and most of the people suffering from asthma have to visit to the emergency rooms. Elevated ozone levels can contribute to higher incidence of asthma attacks, particularly among vulnerable populations such as children and the elderly people. Now, many urban areas are required to implement air quality monitoring systems, and there should be provision of alertness and advisories when ozone levels are elevated. This information will help individuals, especially those with respiratory conditions like asthma, to take precautions and minimize outdoor activities during period of poor air quality, which is you can say it is prevalent in Delhi during winter season. Governments and local authorities should implement strategies to reduce the emissions of the ozone precursors such as nitrogen oxides and volatile organic carbons. These strategies should include regulations on the vehicular emissions, industrial emissions, and there should be control on the emissions, and public awareness campaigns should be done by the government. So undertaking all these the regulations and proper understanding the relationship between the ground level ozone and respiratory health, particularly in the context of asthma, the we government can or people can develop effective air quality management strategies and promoting public health. This will help to reduce the effect of the ozone on the asthma people. Thank you very much.